Okay, testing, testing. I think I'm coming through. All right. All right, we're gonna start here. And I just want to say that it is an honor being a co-organizer with ChicagoRuby Meetup. Anton is sitting back here, is definitely the brains of the operation, and Michelle, who is sick tonight. So I'm stepping in to kind of MC. But of course, Peter and Prarthana are going to be doing most of the great talking tonight. So just want to run through a couple of slides here. So if this is your first time here, we aim to have ChicagoRuby meetups on the first of every month. And this month we're at Prism Spaces. It's actually a co-working space that I used to work at. It's awesome because I live in Westtown in Wicker Park. Super cool vibe here. This is kind of our living room spot that we're in now. So really big shout out to Tyshawn and Olivia who are around here somewhere. I definitely encourage if you're looking for a co-working space to come here. There's a website posted if you want to check out the rates. They have hot desks and it's a great spot. Yeah, and secondly, it's very important is food. And the reason that we have food here at ChicagoRuby Meetup is because of Ben back here. I'm actually, you know what? I'm going to let Ben talk about his business. He's a technical recruiter, and we've all worked with technical recruiters before, and sometimes it's not a good experience. Ben's a cool guy, though. You have to talk.
Yeah, you're going to force me to talk, not let me talk. So happy to provide some pizza. There's pizza in the kitchen that I have taste tested for you guys. It's delicious. We, like Dan said, a year ago, I would have said we specialize 100% in the software engineering space. This year, that's been about 60% of the placements that we've made. I'd say we specialize in like high growth businesses and startups, mostly in the Chicago area. There's been a decent amount of Ruby work that we've done. We've done a ton of like TypeScript and that kind of stuff as well, given the company's net space and the tech stacks that they use. I would say that the thing that we're really good at, as evidenced by the fact that in 2 years of being in operation, we've only had one engineering hire turnover. I think we're really good at matching not like a tech stack, but like companies looking to accomplish one thing, person that they're looking to hire, they're also looking to accomplish something. So we try more so than tech stack's got to match, like people have to know the business. But what we try to match is those two things because we think that makes for an effective hire for both sides, and it has to kind of work for everybody to be the right thing. So if any of you guys need to reach out, I guess look me up on LinkedIn. I should have given my contact info. I'll be sitting over there for a little while, probably having another slice of pizza or two as well if you need anything. Nice to meet y'all.
Awesome. Thanks. Thanks so much, Ben. And yeah, that's Detroit style pizza. It's good stuff. All right, gonna run through these quickly so I can give everyone time to talk. So, yep, here's our meetup link. If you are not currently on the meetup group, this is how we schedule and organize our Chicago meetups. Here's some of our hashtags. Obviously, if you're not in the Ruby Central Slack, we do a lot of communication there. We can get you an invite. Come to me if you need that information. Also hosting, we need people to offer up their spaces. So if you work somewhere, especially if you're a Ruby on Rails stack or Ruby stack, talk to your HR, see if they'd like to have us. We always need space. We don't have much funding, but we have great community. So love if you could have us. Again, you can reach out to Anton there in the back, me, Dan Heinzelman, or Michelle. You'll find Michelle in Ruby Central Slack. I'm sure you've seen her at previous meetups. And also, if you're interested in speaking, I know some of you are brilliant software engineers out here, and I've already talked to some this evening. This guy right here said he is. Love to have you come and do a talk. Scan the QR code and for contact information. Oh, I did not put that back, did I? There we go. Cool. Some other things. I'm sorry, I'm a backup speaker. I didn't look at this slide. Hack night, speakers, marketing, good stuff. Okay. Oh, also, one thing that we're really trying to do at all of our meetups is trying to connect employers with people looking for jobs. So this is kind of a new initiative where we're posting people who are hiring. So actually, Prevail is the company I work for. So if you're looking for a mid-level or senior level full stack developer role, we're looking. I can get you to the front of the line to talk to our CTO and do kind of interview process if you're interested. Also, we have Red Circle and Chime. Noel Rappin, who a lot of you know, is also in Ruby Central. You can reach out to him for a job, etc. We're going to try to expand this list. I don't think we've updated it too recently. But yeah, just reach out to us if you need some more information. Right. Finally, next month, we're going to be doing our meeting at Cisco Systems. Let me get out of the way. And we're going to have Andy Andrea speaking, and that will be great, I'm sure. All right, I think that's it from me. We're gonna have two speakers tonight, and first is Peter. After Peter speak a talk, we'll do a 15-minute break, do pizza, and go back for our second speaker. All right, here you go.
No, I'm gonna
Oh, that's right.
unmute this guy, so let's. All right. And do I sound okay? Great. And let's get the thing started here. All right, I'm gonna. Cool, it's great the way it's not actually displayed on the TV. Let's fight with AV. Hey, there's my presentation. And do you see it on the Zoom, Anton? Great. So hi, I'm Peter. And in 2014, I saw a bug that seemed impossible. I'm sure that's fine. And then it led to seeing a bunch more. And I eventually gave a talk about it. So I want to show you what that bug looked like. It looked like I had this class coupon. And I was a consultant. This was a startup I worked with. And they had this, the coupon code that could be applied to orders. Let's get that out. And then it had a validation that said a coupon can't be both used and expired. It just kind of makes sense that way, right? Like if it's expired, it can't be used. If it has already been used, it didn't expire. And then this worked until a bug report came in. And the bug report, I ran it down to coupon 17439, and I loaded it up in the Rails console, and I got this nonsense, which was the coupon object I pulled out of the database was invalid. And I hadn't even like started editing the object. It was just invalid straight out. And I was like, how did this get saved? I mean, like first, is it this validation that's failing? And so I pulled it up and it was like, well, yeah, if I say full messages, I get exactly that message. And if I look at the two timestamp fields, they're both filled in, which is the exact thing the validation is supposed to prevent. Like it's a simple validation when we look at it. And it's kind of like a locked room mystery, which is the mystery novels where the clever detective has to figure out why there's a dead body in a room that's locked from the inside. Like, how did the killer do it and leave no trace? And when you see a bug like this, that it's like, come on, there's like one line of code. What happened here? So I promise I won't call on anybody, but can you raise your hand if something like this has happened in your app, where you find stuff in the database that should not exist? All right, at least somebody. The clue is that this is not a mystery. This has happened before. So the talk I gave about this was 2016. And I talked through a bunch of ways that we ended up with invalid data persisted in our database, and I gave some ideas for trying to fix it. And you may have noticed that I failed, that like this still happens. This still happens on apps. And I also realized the problem is a lot more big and pervasive than I thought, because there's a tool that's been missing from our toolbox. And so this talk is about that we actually can't make our databases perfect. We can't make our data perfect. And that's actually kind of okay that these bugs will keep happening. I will put these slides online after everything is online, and so you don't need to take photos. And I'm a really private person, so don't post me online, please, which I appreciate. And let's dive in. So when I talk about how we have safe looking code like that coupon that persists invalid data to your database, I want to talk about how it's not really one bug or it's not one sloppy practice. I know 9 ways that these things happen, and I'm lumping them into like 3 broad categories based on kind of area of responsibility. And it hurts me to admit, but like all of these things are trade-offs. They're not just design issues that we can fix. They solve real problems that are generally much more valuable than the bugs they create. The first one is kind of a gimme. Like everybody knows in Rails, you can call save validate false. It's very obvious and you try not to do it, but sometimes, especially in migrations, you kind of have to do it because you might have poorly designed validations and persisted invalid data. We've kind of all been there on that one where we're trading off our time against correctness. There's a closely related, I call it kind of a bug factory in the Active Record API. There are 19 methods that skip validations, like save false, and they don't have a clear naming scheme, so you just have to memorize them. And I tried to kind of, they're mostly here for performance reasons in Rails. Like they're a low-level way to nudge a attribute like increment counter and decrement counter, and there isn't a clear pattern in the naming. So I tried to kind of like vertically group them by function and then horizontally by whether they have a bang method. And in this context, a bang method doesn't mean it raises instead. The bang method means that it skips validations. Like there isn't a non-bang decrement. So like it messes with a lot of semantics in Active Record that we're kind of used to. And honestly, I would be fine with all of these if every single one of them had the word unvalidated on the front of its name, because it's like, no, I want these little performance hacks. I can't memorize these. The next one that's real common is orphaned records. So if we went back to that coupon, we could add a line of code that said, if a coupon has a link to the order it was used on, we've got a little foreign key. And this is the correct way to write this validation in Rails, but Rails won't actually enforce this foreign key. You have to know to add an extra option to your database migration. It's kind of a historical cruft. It comes from this blog post by DHH in 2005, so 20 years ago. He said that he wanted a single lever of cleverness, and all of his validation kind of code should be in his Ruby objects, not in his database. And since then, Rails has gained support for most SQL database constraints, but it's still not the default. So we get bugs like that we could trivially avoid. So I kind of think this one is the worst of the trade-offs. Another one, if you edit validations and you don't memorize or remember that you have to make a migration for every time you edit a validation, well then like now the definition of what is valid has changed. So if I added a length to that coupon code and then I didn't write a migration that said we have to go check all of them and like edit the coupon code or do something or change that length to be only on create, it's just kind of a foot gun in the single layer of cleverness idea that there isn't support from our tools. We've got a couple of decades of safety engineering research, like why do planes stay in the sky instead of crashing? And what we've learned that when a process relies on a person having to always remember to check every box, the result of that is failure, not success. Humans can't memorize 19 methods that might be save invalid data. They can't remember to always create a migration. I mean, I can't even remember to always run the test suite before I push up to the branch. We have to build systems that support our normal human limitations and not punish us for them. I gripe a bunch about the single layer of cleverness, and I kind of called this section mostly Rails for like who's kind of responsible, but it's not that Rails is especially bad here. I've used a bunch of database libraries in a bunch of different languages, and all of them have design limitations. All of them make performance trade-offs. So like other libraries besides Active Record, they won't have this exact list of issues, but they will have a very similar list of issues. So concurrency is hard gets us into race conditions where It's not research like safety engineering, but we do have a couple of decades of proof by experience or proof by example that when a system has multiple programs sharing mutable state, humans write race condition bugs. The coupon bug I opened with turned out to be one of those. So if you remember when I looked in the console, there was another little clue here that maybe somebody who's seen a bug like this might catch. It's a very Railsy hint that these two timestamps are identical. And the really, really Railsy hint is that they're both between 30 and 90 seconds after an hour. And this one I learned as a consultant seeing different apps, because it takes 30 to 90 seconds to boot a Rails app. So your hourly cron job touches data typically 30 to 90 seconds after the hour, which is a great setup for having a race condition because of partial writes. So if you have two jobs running at once and they touch the same record, or you have one job running on that hourly cron job and a user is editing things at the same time, you can get a bug. And that was what happened with our sad coupon. We started with a coupon that was in a valid state where it was neither used or expired. And then the used coupon, the coupon got used on the phone and recorded by the customer service person. And it went and said, okay, great, let's save the coupon and add that timestamp. And then at the same time in the background, the job went, this coupon is too old, let's expire it. And so both of them wrote to the database, and we ended up with an impossible combination of facts. And each side thought that they were correct. This is, it kind of took me forever to figure out the first time I saw it, but now I've seen it a few times, and it's like, oh, okay, wait a minute. The timestamps are such a smoking gun. There's another race condition in the other direction with aggregates, any kind of record that only makes sense together. So if that coupon connected to an order like this, an order is an aggregate because it only makes sense with its line items, and the line items only make sense with the orders. And I wrote a little code that said that the order's total price is the sum of the line items minus the coupon's discount. That's totally straightforward. But the bug comes in that Rails, when we load the order, then we separately load the items, and then we separately load the coupon, and there's active record, there's caching inside of active record, a couple of layers. So even if the code looks straightforward, it is totally possible that some other piece of code 1,000 lines before loaded one of those objects and active record pulls it from cache. And now your aggregate is loaded from an inconsistent set of states, perhaps over several seconds of state, which is plenty of time for background jobs and user interactions to start changing things. So you could end up with things like an order that gets a coupon that's already expired, and then the used ad is even after the expiration. Or it applies only to particular items in the cart, and they're no longer in the cart after the coupon has been applied. Rails doesn't create a read transaction even when you do eager loading, because it really wouldn't be appropriate for every association. It only makes sense for aggregates, and it would have a significant performance penalty. So again, like, it's a trade-off. And speaking of trade-offs, there's a really painful one, which is we kind of have to have interfaces that have reduced validations to find and fix bad data or handle really unusual customer support issues, like the Rails console or the SQL database console or our own admin interface. And these privileged interfaces are places that humans make mistakes. And it can be as simple as they retyped the order number or they retyped the coupon code and they had a typo, but the customer support agent doesn't have to run all of the validations because they're fixing prior errors. And you usually have to be able to skip validations to fix prior errors. Audit logs and systems that require pair programming and sign-offs can help with this kind of thing, but not eliminate, because again, now you're making a trade-off of more time and more complexity against fixing other bugs. They're kind of just unnecessary risk. And having two programs or two code bases that both talk to the same database is kind of an infamous anti-pattern, where like maybe your Rails apps has a set of perfect validations, but then the Java ETL program by those other devs over in data engineering writes to your database incorrectly. And it would be really tempting to say this is caused by the single layer of cleverness and put up with it, but it's not actually about a database. it's really anywhere that you share data between programs, whether that's a SQL database, your job queue, the file system, a well-specified API, all of those are shared data. So there are opportunities for the two programs to slip out of sync. So we can take responsible steps to minimize these things, but we cannot eliminate them. And then there's a pattern that everybody does, especially when they integrate third-party APIs, where we often create a record in a slightly invalid state and then come back to it, like in coupon. Maybe we create the coupon and we have its Stripe token and we leave that as nil. And then we just stick a job in the database that says, go talk to Stripe and get the token and save everything, and then come back and fill in the nil and save it. And then like one time in a million, we happen to deploy the job server while the database server is overloaded and the third-party API is in a brown edge and Mercury is in retrograde and the job enters some like weird partial state where it never finishes, but it never fails. And then you're like, you just have a nil on this token that should never be there. So it's kind of a lot of ways to end up with invalid data in your database. And I know I'm not being exhaustive. Like, this is all things I have seen in real bugs, in real code bases, at real clients, but I haven't actually spent a lot of time working at scale. So I am sure that there are people in this room who could improve this list. If you count it as improvement, expand the list, maybe, let's say. But also, like I said, these things are trade-offs. Like, everyone makes trade-offs. But I'm sure somebody doesn't agree, somebody watching this or present. Because I always hear about golden hammers and silver bullets that'll fix these problems at a reasonable cost. The one I hear about most is SQL constraints. So in this create table statement, they're the bolded parts. Like we talked about a coupon getting disconnected from its product. I think these are great and that we should use them everywhere. There is a gem called database_consistency, and I think basically every Rails app should have it installed. Active Record supports these kinds of basic constraints, but it doesn't actually support more complicated constraints. So an example that Rails doesn't have great support for is that if I want to constrain that a coupon expires, it has to expire after it became usable. I mean, you'd have to use schema.sql, and you'd have to write the SQL by hand in your migration, and you would have to duplicate the model in your validation. And the exception is a string, and they're just kind of clumsy to use. Even if Rails added support, SQL constraints have some big limitations. They only run on insert. They can't compare the new data against the data that already exists in the table or other tables. And they can only express a really limited set of concepts. So I can't write a constraint that a coupon has to start after all existing coupons have ended. And I can't say that a unique product ID can only have one coupon active at a time. And I can't join against the products table to prevent creating a coupon for a product that says it's discontinued. These are all like natural things I would like to write constraints for, but SQL just is not expressive in that way. It does have a useful kind of feature along these lines, though. So if we go back to that thing about you insert a null and then you replace it, like everybody does this because it's easy to code, the user gets a fast response, and the background job automatically handles retries and rate limits. I would like to be able to write a SQL constraint for this scenario. And I can write that Stripe token is not null, and Rails supports this, but that's not what I want. What I really would like is to write a constraint like this. That, yeah, like the job runs, and then, look, just giving it to it, right? But like, it's like a 5 nines kind of constraint. It's not perfect. The other golden hammer I hear a lot about is SQL triggers. And a lot of the time when people say constraints, they mean triggers because triggers are more expressive. I had said that we wanted to have a constraint that works across tables, like, no coupons for discontinued products. And we can write that as a trigger. A trigger can express almost everything that you would want to say, but you don't want to have to say it in triggers. This is not my favorite programming language, and not just because it's Ruby, because like here, you can see on the slide what I want to say, but this is what I have to say. there is a lot of boilerplate, and it's not a great development environment. And if you try to do this in Rails, you have to reinvent a lot of wheels because you will have to express basically all of your business logic in this kind of syntax. And you would have to write a trigger for every line of business logic that changed persistent state, which is to say all of the business logic that's worth writing. You'd also have to roll your own integration with source control, your own connection with your deployment tools, your own internationalization, your own test suite, your own performance monitoring. It is almost enough to make me accept the single layer of cleverness. I would really like to write something like this in succinct Ruby and have it enforced in the database. Like this would be great. That's what I want to say. There are some more techniques I hear about that are less common, like formal methods or like a really clever testing techniques or functional programming. And I don't have the time to hit all of them, but they all have significant limitations and they absolutely have significant costs. If you have to spend thousands of engineering hours to build infrastructure around it and it halves your shipping speed, it's not a good trade-off. It's also not sufficient because you'd still have problems with less expressive SQL databases and non-SQL databases like MongoDB and Files and S3 or every third-party API that you touch. Those are all databases. They all have their own data integrity problems of their own. So, ouch. Let's kind of take stock. Our databases have invalid data. We don't know all the reasons it happens. We can't prevent it. From our apps, we can't prevent it in our database. We don't have a golden hammer to fix it. We don't know how many bugs we already have. We don't know how much data we have that's already invalid. But we did figure out something important. We don't actually need perfect. The world is not on fire. We can't really afford perfect. We're used to making trade-offs, and we're also used to dealing with compilers and test suites where you've got to be perfect about like every single comma in a million-line code base or the program won't even run. And our experience as programmers has trained us that we have to have these perfect solutions, that if it's not types, maybe we'll get perfect from constraints and triggers and functional programming and domain-driven design or formal methods or agile or expensive consultants or shoving flaky LLM features into every goddamn IDE, whether or not they work. But we don't need perfect because we are engineers. We're building systems that do productive things. We're not deriving mathematical proofs. We're certainly not computer sciencing. We are engineering. We're making trade-offs. And all of these problems are trade-offs. So all of the solutions are trade-offs. I had said earlier that my current best guess for where, I forgot to say that earlier, but I think roughly half of all apps will have a data integrity bug and persistent invalid data when they have 250,000 rows in the database or like 3 years of active development. And this is my best guess. I'm kind of refining it. And these seem like pretty low numbers. Or to invert that, I'm also saying that I think these bugs happen roughly 1.25 million records, like really roughly. Please don't hold me to it. It depends a lot on the specific situation. I've seen some of these bugs that happen 1 record in 10,000, and I've seen bugs that happen to 1 record in a billion. And that one is like especially not too bad. But as your app grows, you might end up touching 250,000 records in a day. And it's sort of funny to think of like a 1 in a million bug as a daily problem because that's lottery odds. Like, congratulations, you've scaled. You have won the startup lottery. Would you like your bugs as a lump sum or in 30 years of installments? Yeah, and that's a joke because you have to take daily installments. You've been added to PagerDuty. So speaking of companies that won the startup lottery, I worked at Stripe for a couple of years. And since I'm going to give a dollar amount, I should mention that I joined around Series E. Don't get any wild ideas about my net worth, but Stripe certainly deals with a lot of money. Stripe announced that they processed $1.4 trillion last year, which means they processed $3.8 billion a day, which is a lot of chances for a 1 in a million problem. And when I started there, Stripe taught me about an internal system it had developed that checked for exactly these kinds of data integrity bugs, like that coupon bug. And then I've been talking with other developers at other companies, and I have found another half a dozen independent reimplementations of the idea. And the surprising theme of these systems is that developers generally think that they're terrible and that they are invaluable and can never be turned off. Because nobody builds one of these on purpose. Like they have a bug, they repurpose an existing tool for finding persistent invalid data, and then they reuse it for more bugs, and then they bolt on like a Slack bot or other teams start using it, and then it's like load-bearing infrastructure, but it's nobody's full-time job to improve. And so then it gets dumped on an ops or a database team, but it's a pile of hairy code that doesn't move any of their existing KPIs, so they sure don't love that new baby. So I built a new open source version, one that we could love, even if we don't love all of the bugs that it finds. It's called Recheck, and the core idea is really simple. If we can't prevent persistent invalid data, we will check and recheck our production database for it. It's not about being perfect, it's about making good trade-offs. So let me show you how it works. I run this website called Lobsters, and the quick intro is that it's a discussion forum like Reddit or Hacker News, but it's much, much smaller and just about programming. But even a small community can be pretty big. The database has 7.5 million rows, and we've been under active development for 13 years, which, if you remember my 250,000 or 3 years, yeah, we have data integrity bugs. And I will show you them. And I'm going to skip over live coding because of AV setup stuff, but I'm aware that asking for doing live coding in a talk on software reliability is just kind of asking to be struck down for hubris. And so I took screenshots of the things I was going to show. So using it looks like this. It's add gem to your gem file and then run bundle install. And then run a single command that says Rails recheck setup. And that introspects, it boots the Rails app and it introspects the models and it creates what's called a check suite, a suite of these checks for your models. And so, Lobsters, you saw the screenshot. It's got all those things like vote and user and tags that you saw before. So recheck introspects on all those and can create some basic checks. This is kind of the bottom of the output. Oh, one of my favorite features is it looks and it figures out which linter you're using and then runs it so the code looks like your code. I'm so satisfied with that. And if we go and look in Lobsters at a story, like one of those headlines on the homepage, this is out of the active record model. It's got a title, a description, a URL, all those kinds of things, and then validations. So like that very first validation on the slide is that the title is between 3 and 150 characters. And so this is what a generated check looks like from it, where we say things like, we automatically can say, hey, if we have a presence validation that there's a token, we can turn that into a query that says, hey, are there any stories where the token is nil or where it's empty string, because that's how allow blank works in the validation, or the lower one here, query the length of the title. All right, find me any title with a length that's less than 3 or over 150 or just missing. And if I run that check with the tool, it runs against the database. And then, no kidding, this is, I promise you, this is 100% real data. It went and said, oh yeah, you've got one story that fails that query that titles have to be present. It is story 84,270. And I pulled it up. And indeed, the story is not valid. And if we look at the messages, it's that the story title is too short. And if we look at the story title, it's missing. This is exactly the coupon demonstration of we have persistent invalid data. I did not know this record was there when I first ran this. And I was like in heavy debugging mode on Recheck. And I was like, oh, I have a bug in Recheck. And then I was like, no, wait, I have bad data. It works. So it was kind of, happy but irritating, which is a lot of the experience of using this software. So when we see these kinds of bugs, we have to go and check the database and see, like, are there any others? Can we deal with them? So let me show you like one last example, like from an ordering system. If we had a user and they don't have an email address, they better have a mailing address or a phone number. So if you found a user in your database who, through some combination of bugs, lost all of that associated data, and like you'll get the bug and you'll investigate it and you'll fix the bug, hopefully, you think. But then you'll also write a query that looks like this or looks like the raw SQL version of this to say, hey, are there any other users besides the one that complained that lost all their contact info? So if you take that query you already had to run as a responsible developer and you add a little boilerplate to it, hopefully this is not as bad as writing a SQL trigger. Recheck as a system can run it continuously in the background and tell you immediately 9 months later when the bug comes back or some other circumstance recreates the bug. So the real value of Recheck is taking this work you already do and giving you peace of mind that difficult bugs have stayed fixed. And even if they don't stay fixed, you know before your users do, and you give yourself a huge head start on fixing it. Because the most valuable line of code in this slide is this comment where I have left a note that says, this is the bug that we saw. This is the link back into the bug tracker. And if you put your notes from the bug hunt in there, it's a lot like an automated test of your production data, which is a gift that you give to your future self to find and fix problems faster and with greater certainty. And this trade-off is great. I will take this trade-off all day because I take the query I already had to write, I give it a name, and my system gets permanently better. I think you want to write checks because perfect is too expensive. That is what checks are for. This is why I'm writing Recheck, which is in fairly early beta right now. It is incomplete, and of course, it ironically has its own bugs. I'm working on it, but it does work. And it has caught real production bugs in Lobsters and now also in other apps. Since I gave a version of this talk a couple of weeks ago at ChicagoRuby, folks have started using it and have said, thanks, now I have more problems. But the thing is, now they know they have more problems. So it is a little better than like the check engine light that comes on and doesn't tell you anything. This is the kind of tool that I think has been missing from our toolboxes for the last decade. I would love it if you would give it a try and tell me how it goes on your app. I have some availability. If you would like to beta test it, I would be willing to pair program with you, whether that's here in Chicago or remotely, and help you get set up, because I think all of us should have fewer bugs or at least fewer pages about bugs. Thanks for your time. Anton, I don't know how we're doing on time, if we have a minute for questions or like 1, 2, if anybody's got a question.
What's the rule of thumb for what checks you actually add to this automated system and which ones you leave out?
Anytime you have to. Oh, yes, of course. What's the rule of thumb for when you write a check? It's anytime you have to go look in the database for bad data, just do yourself a favor, copy and paste that. Anytime you write a background job, there is just something about them executing in a slightly different context and very often dependent on third-party services or other integrations that just attracts these kinds of bugs. Or the third one is anytime there's money involved, because, or, whatever is closest to the value of your product. So this kind of list is also very close to when do you write automated tests. So one of the ways I explain this is these are like unit tests of your production data. So a lot of the intuitions you have around automated tests are very valid here.
Sure. Query in the database. It's not, but it's
Yeah.
also.
Yeah, so it is a query, and then the way this works is it's a very general purpose tool. So you can query for any kind of bad data or any kind of record, and then write a method called check that says, is this record actually bad? Because sometimes it's a lot easier to express what does bad mean in code instead of in your query. So one example that I have in the README is like, find me any user who has an avatar image saved and saved more than a minute ago because LDAP propagation takes a minute. And then that just queries for records. And then the check method would say, okay, well, let me go check the third-party LDAP service to make sure that those images uploaded, or check the S3 bucket to make sure it's there with a non-zero file size. And so the recheck is a runner that calls all your query methods and then calls your check methods for each. And so it says, hey, if this check method is saying false, then I'm going to consider this bad data and report it to the user. And you get output that looks like this, which is like not the greatest output, but it's the name of the checker, the name of the query and check that failed, and then the IDs, but it's designed to be a general purpose tool, so you can get JSON output, XML output. You can write your own output plugin that shoves it into Jira tickets or emails, whatever is your favorite way of hearing about bugs.
Would you condition that just have a second query?
Yeah. Yeah. So query could even be as simple as like user.all. And then the check could say, oh, well, let me go and hit this third-party service to make sure that the user's avatar uploaded, or that they have an entry in the email service, or all of these other things. It is not actually database specific because my definition of database is pretty general. It's not just SQL, it's any place that you store data, which is often with third parties. And then you can either manually run it or you can set it up to run continuously in the background. And Anton, unless we have any questions from chat, okay. So we're going to take a quick break, and I don't have it is 6:54. You said 15 minutes for pizza? Okay, so we'll come back at 7:10 Chicago time, and we will get the next speaker set up on the TV. It's a great idea, can I?
Hey, Anton, I can try sharing my screen. It does, I don't think I have. Oh,
One 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 one. Oh, okay.
I,
Do
I
you hear
will
me?
have,
Do you hear
yeah,
me yet?
I can hear you, yes.
Okay, great. Because I had some sound issues, so I couldn't speak before that.
Yeah, it is asking me to quit Zoom and restart for me to share.
Uh,
I will
yeah,
quickly
yeah,
quit and,
of course. Take your time. I'm here when you're back.
okay.
One one. One one. One one. 1 2 3. 1 2 3. 1 2 3. Oh, okay. Give me a second. I need to make you a co-host once again. Okay. Now I believe you should be able to screen share and unmute yourself. Oh, yeah, yeah. I see your slides. Can you unmute yourself? Unmute yourself on Zoom. Oh, yeah, yeah.
Yeah, can you hear
Okay.
me? You
Uh,
can see the screen, right? I can't
yeah.
see it over here though. I don't know why. Let me change my view. No, it does not. Okay, so basically okay, and just a second, and then let me, so you can see my, can you also see the header up top?
Yeah, yeah. We
Oh
see
no,
everything.
it sees, yeah, how can, let me try sharing just the Chrome thing. Yeah, it still says City Ruby on top, right? I think that's okay, maybe.
Give me a second. I'm figuring out how to make everything work. I pinned you, but I can't understand how to unpin you now. Okay, I think I'm close.
Yeah, like a presentation, like it should take the whole screen. I don't know why it's opening like, or maybe it's like in Chrome. That's why maybe I should have downloaded it, and that's fine, right?
Uh, so I don't see your screen.
Oh, you
Can you
don't see
try
my,
to?
Oh, you don't see my screen at all?
Give me a
Oh.
second. Maybe it's not you, maybe
let me,
it's settings. Yeah, try to share, please.
okay, let me, is this better?
Yeah, great. I see your slides.
Okay, is it okay?
Yeah. It looks great.
Okay. Yeah, it's just like little. Okay, yeah, I think.
Okay, I just think how to position everything correctly.
Okay. And you can't see my speaker notes, right? You can only see the presentation.
No,
Okay.
I can't see anything.
It's-
Yeah, okay. So I'm just doing several more things on my end.
Okay, okay.
Okay, so now we see you and we see your slides. So I think it should be great now.
All right, perfect.
Okay, and we hear you. Do you see the audience? Yeah? Do you see me?
Yes, I can see you. Yes.
Okay, so everyone is just grabbing some pizza. So I think everything is good. We have everything. We have sound, we have video. You see the audience sees you. So yeah, I think everything looks great. So give us like maybe 5, 7, up to 10 more minutes. Okay. We will
Okay,
just finish our break and then we will transfer the word to you. Okay.
perfect. Thank you so much.
Okay. Yeah. Thank you. Thank you for joining us and thank you for being ready to speak. So yeah, I will pin you a little later.
Okay.
can speak. Prarthana, are you ready? Are you in Dutch?
Yes, I'm ready.
Okay, sounds great. We are also ready. So let's,
Okay, yeah, I can get started.
yeah. So over to you.
Hello, everyone. Very nice to meet you all. And yeah, thank you, Peter. That was a wonderful talk. Recheck seems amazing. I'm looking forward to using it. So a little introduction about myself. My name is Prarthana, and I am based out of Los Angeles. I live in Burbank. I have, over the number of years of experience, I worked through different technology stacks from Microsoft .NET to Ruby on Rails in the last 10 years, Python, Postgres, a lot of databases. My journey has taken me through a lot of consultancies like Accenture, McKinsey, as well as dynamic startups like NextHealth, where I'm working right now. At NextHealth, we are focused at transforming healthcare through technology by connecting doctors, patients, and developers. We integrate with different electronic health record systems to build a SaaS platform, which makes it really convenient for patients and streamlines doctors' offices' day-to-day processes. So yeah, like today, like I said, I live in Burbank, which is really next to Hollywood. So I thought that since I live in the center of movie making and storytelling, so I will tell you a story of how we transitioned from a row schema-based multi-tenancy to row-based. And yeah, this story was written, directed by our engineering team. And yeah, I guess I can say we did pretty well. And we were able to, well, yeah, it was like a blockbuster hit. So a long, long time ago, when NextHealth had just started, we decided to go with schema-based multi-tenancy. It kind of made sense then to isolate each customer's data in its own schema, so there was a logical separation of data, and having a tenanted-based database made sense. We could control the access at the schema level, and because we definitely had a lot of PII information, so keeping them in their own schemas was the way to go. And this is an architectural pattern which quite a few companies use. And initially, it was all well, till the company kept on growing, which is a good problem to have. We kept on acquiring new customers, which meant that we needed a new schema for every new customer we acquired. So most databases generally have practical limits on the number of schemas they can efficiently handle and potentially scale. But as we kept on growing from hundreds to thousands, maintaining those many schemas started becoming a big problem. If we had to aggregate across different schemas, we were writing really dynamic, complex SQL queries. Backing up and restoring individual tenant data was becoming more and more complicated. Some tenants were much larger than the others. So there was this performances imbalances which we were seeing. So just to give you an idea, so like for a multi-schema based database, each schema is a replica of the other. So basically, if I had 50 customers, 50 schemas with 100 tables each, we were at like 50,000 tables together. And Postgres kind of treats each of these schemas as individual databases. And the way Postgres works is that every time we delete or update a row, it runs this auto vacuuming process, which then clears up these dead tuples and gives the space back to the database. But as the schemas kept on growing, our auto vacuuming process started lagging. Like there were times when the process used to not even get done. It kept on getting slower and slower, which resulted in a lot of latency in the queries. And when this auto vacuuming process runs, generally the database becomes really slow. It's generally done during the night, but because our database was so large, we were having to run this much more frequently, again, resulting in a lot more latency. And the way we were managing all of this was by using the apartments gem. So the apartment gem initially made it really, really simple for us, switching between different schemas, our migration management, tenant creation, and deletion. So initially, when everything was small, it worked really well. But as the number of schemas started growing, the migration started becoming painfully slow. And then apartment was also not really good at cross-tenanted queries. Plus, at that point of time, apartment was really not very well maintained as a gem. So we were seeing a lot of problems. So basically, we knew that we had to get away from this multi-schema database. We had to consolidate all of these shared tables into one row-based multi-tenant tables. And that was the way to go if we wanted to keep on scaling and keep on growing. But one thing, and I might not have mentioned before, but Nexthet also has developer APIs. So basically, we already had developer partners who were using our endpoints to build their own products. So we had to make sure that we were maintaining this contract. We were not changing it. So how it works is that, for example, I have an appointment table. So this appointment table will get repeated in each and every schema. And the appointment, the primary IDs like 1, 2, 3, 4, and so on will be repeated in each schema because they are logically separated. But if we are consolidating them into one, this means that there's a primary key conflict. We can't without doing a material change. So basically, if we had to still maintain the ID column to maintain the API contracts, we had to somehow come up with a solution which still maintained the original integrity while collapsing all of these tables into a single table. And of course, while we were at it, we thought, why not come up with a solution where we change as little code as possible and get everything done really fast. So the first idea which we came up was actually pretty straightforward. Why not create a composite primary key? We already had the ID columns, and we already had the institution IDs, basically the client IDs, which identified each unique customer which we had. So basically, if we were to create a composite primary key with the institution ID and the primary ID, then we could still merge these tables into one without having a conflict, because a unique combination of an institution and an ID, institution ID and an ID would still be unique, and we could consolidate it. So this seemed like a great plan, except that at that point of time when we were doing this in 2021, Rails did not natively support composite primary keys, which meant that we had to use composite primary key gem, which again meant that we would have to do a lot of monkey patching, like just make active records work. So it would be a lot of coding required to make this work. So the next solution which we thought was to use UUIDs. GUIDs are generally very scalable. They are much more unique. They have global uniqueness, and we wouldn't have the problem with the old numeric IDs. So that seemed like a great idea, other than the fact that if we were adding UUIDs, now we would have to not only change the primary keys, but all the foreign keys would be changed, all the relationship integrity. So we had to make sure that we were changing it everywhere. And UUIDs in general are not readable. Also, they take much more space. They are 128-bit, which is generally bigger as compared to integer. So there were a few drawbacks, but UUID seemed like a good option to go with. And the third solution which we thought was that why not just make the IDs themselves much more unique in their own schemas. So every schema which had like 1, 2, 3, 4, the regular primary IDs, why not calculate with an offset and make these IDs much more unique, so that when we consolidate them into one table, we don't get the primary key conflicts. But this was a lot of math which we would have to do to make sure that all the keys in all the schemas were unique. And also integers at the end of the day were finite. So we finally decided to go with the most complex solution, which is to use UUIDs, because we were anyway going to make a big change. We knew this was going to take a long time. We were already kind of talking with management, letting them know that this was a huge project. So we thought, why not, since we are already at it, come up with a solution which is much more global, which will scale better. And even though it would take more time, this was the right thing to do. So we had an idea that we had to use UUIDs, but our customer base was growing every day. Like every day we were acquiring new customers and we were already at the threshold. Like we were bursting at the seams, and we had to do something really quickly so as to give some leeway for the new customers while we actually penned down the solution and made it work. So what we did was that first we went through all the schemas for the churned customers and dropped them. So that gave us some additional space. And then the other thing which we did was that with the apartment gem, what you can do is that you can let it know that, hey, these are a set of common tables, so let them live in the public schema, while only the tenanted table go in the tenanted schemas. So we already had a bunch of tables which were common to all the customers which lived in the public schema. But in the way we were replicating the schemas, we were always copying the tables, even though empty, in all the schemas. So what we decided was, let's drop these empty tables. That meant some additional work because our migration script, we had to change it, but that meant that we got enough headway that sales could make the sales while we built our new system. So just to give you an idea of how long it took, we started in 2021 and we completed in 2023. So it took us 2 years. And when we started, we were over 200,000 tables with 3,000 schemas. When we ended, we were at like around 7,000 new customers. So that's the kind of growth we saw while we were making such a big architectural change to the database. And that is why I think also where we went really slow, it was a tedious process, but we needed to make sure that we did not break the application. So since we were only getting started, we had a plan, but we had not tried it. So we basically made a categorization of the models which we wanted to start with. We started with models which were the least priority. So even if we broke something, we knew that the whole application would not go down, or the doctors would still be able to use our services. So we picked up a bunch of models which were like low hanging, which did not have very major functionality, and we started with those. We met with the stakeholders, made sure we understood what it was doing and what were the different effects, what were the different tables which it used. So came up with all the queries it was using, decided on the plan on how to fill the UUID. So what we realized was that if we had PRs, which had the migration script, like, add the new column with UUIDs, backfill with the UUIDs, add new columns for institution ID, add indexes, the PRs used to block the whole deployment process. So for non-production environment, we decided to go with PRs, and for production environment, we had them as rake tasks, which we ran during the night so that it could be as efficient as possible. We also did one more thing. So we had already like almost 3,000 schemas when we started. So we knew that we couldn't evict one table from all the schemas together. We had to take a phased approach. So what we did was like in the apartment gem, where it decides when to switch to a public schema versus the tenanted schema, we made the path such that first it always checked in the tenanted schema. If the table was there, it used it, else the fallback was public. So even if the same table was, for some schemas present in the tenanted tables, for some customers present in the tenanted tables and not for the rest, our code still works. So this allowed us with the gradual deployment of the gradual eviction. So just to give you an idea of how long, how much work evicting one table took, it took us 21 PRs to evict a single table. And we also wanted to make sure that we had all of these steps, like while once we had kind of evicted 10 tables, 10 to 15 tables, we had nailed down the process. And it was really important for us to make it really consistent because we couldn't have, the engineering team was really small. So we wanted to make sure that if we had contractors on board, they exactly knew what they were doing and they would be able to scale this effort much more faster. And we also, as a byproduct of this project, what we realized was that we needed to make our production deployment process itself really fast, really mature, and really efficient. So as a part of this project, we actually managed to come up with really good ways, very efficient ways to deploy, which we still use till today. If I were to say that we did not have any incidents, that would be a lie. We actually broke a lot of things, even though we were very, very careful. Just kind of mentioning a few. So when we added the UUID column, there was this one table where before sending reminder emails to patients, we checked if an entry was there or not. And we forgot to put the not null constraint on the UUID column, which meant that we were able to enter records without an ID, which then meant that when we looked for a ID, whether it was present in this table or not, we basically saw that, this patient has not got a reminder, and we send multiple reminders to the same patients. There were things where we forgot to change the integer data type to UUID. So what happened was that it just picked up the integer part of the UUID when we were backfilling it. We forgot to scope things by institution ID, which meant that now without the scope, we were incorrectly calculating the metrics. We were incorrectly sending wrong information of how the different customers were doing because we were using a much bigger, a broader set than we should have. We broke our appointments page. So basically, we did kind of do a lot of, we did have a lot of incidents, but in the end, we finally made it. And I think the lessons learned for us was that no matter, generally in startups, you will start a certain way, and then you will realize that, you can't go on with this. And in order to scale, you need to pivot. And I think it's totally fine to make these pivots and make these changes as long as we do. And I feel definitely when it comes to databases, no matter what we do, even if, now we've put everything in one table, it has other problems. Like now one table is too big, so we need to partition. So we are always optimizing, always trying to think of things which make the database much more scalable, much more efficient. But in the end, we were able to accomplish what we had started. And that is it. Thank you. If you had any questions. I'm sorry if I went really fast. I can't hear if.
Right now. Can you hear me now?
Yes, I can hear.
Okay. What was the original business reason for creating all those different schemas or namespaces for like every different user? Like what was the original problem that solved?
So I think when Nexel got started, basically the co-founders, they were the ones who were doing the coding. They were just fresh out of college. And basically that's what our CTO says. They went and did a Google search, and the first option which they got, they kind of used it. So I want to say that there was not a lot of thought which was put into this. They just kind of started with something and it continued. Also, I think because this was like in the health tech space, it made sense to keep these schemas logically separate so that there is no data mix-up, and we make sure that the customer's data is its own logical, it's logically separate. But of course, we know we can still do that in row-based multi-tenancy. But I think it was mostly because they really did not have a lot of experience to decide what was good versus not so good.
Thank you. Anything else?
Sorry, any?
Oh,
There's a question in chat.
sure.
Oh, is the
Hi,
question?
oh, somebody has a question in the chat.
I will. Oh, let me read it. So we were, when we started, like I was the 17th engineer who joined, and I think we started at 20. So that's it. Like we were 20 engineers, and that also we were only 3 engineers on the back end. So we were the 3 who kind of came up with the plan and we started. We did get more contractors, like around 5 to 6. So towards maybe not exactly in the beginning, but maybe 3 to 4 months down the line, we might be like 6 to 7 of us.
Yeah, well, I guess I can ask my question now. Did introducing UUIDs affect how you modeled your API moving forward?
Yeah, so we always had to make sure that the ID column was still maintained. So today we still have the legacy ID, we still populate it, and that's how we still maintain that contract. For our internal purposes is where we use UUID for the foreign key integration and references for the uniqueness, but we still have the legacy ID column.
What was the effect on storage cost to switch over to UUIDs? Because that was the trade-off you mentioned. Like, did that turn out to be a bigger problem or a smaller problem?
Yeah, like I think nowadays databases are generally cheap when it comes to storage. So I think that was one of the problems which we initially thought and we considered. But as of now, yeah, till now, I've not seen anyone complain about it too much.
Yeah.
Was there another question in the chat? I thought I saw. Just a response from Dave.
Oh.
By the way, it's quite your so you can just say when you see it's
Picking up, yeah.
I guess if I don't have to stand up, I'll follow up with your question. Was there a difference in performance when you added the UUIDs? I've done this once before, moving from IDs to UUIDs, and performance was an issue with certain versions of UUID because it took longer to index or something there.
Yeah, like I think it was in general a very long. I think I should be like focusing at the fact that adding UUIDs in itself took a lot of time, just changing all the foreign key constraints. But I have not seen UUID in generally making things slow because we still use IDs for indexing reasons. Like in the where clause, we'll still use IDs. So I think it's still okay, but you're right. They can definitely affect the performance.
Why does it affect the performance?
Straight compare.
Okay. Got it. Yeah.
Yeah, and I think if you add indexing to it, it'll be better, but yeah.
Most databases do have a UUID data type that's more efficient than a string, but it's still slower than an integer. Right.
Okay.
My question is a little more basic. What's a UUID
Universally unique ID.
and what's the difference between that and a regular ID?
So like an integer is going to be like 1, 2, 3, 4, 5. You can pretty much guarantee that that's going to conflict with like another database that starts from 1 and goes up. UUID is, I think it's 128 bits. I forget exactly how long it is.
128.
What was it?
Yeah, 128 bits. Yeah.
Oh, yeah, 128. So the chance of 2 UUIDs colliding, if it's done well, is 2 to the negative 128.
Oh, wow, okay. Okay, thank you.
okay. Prarthana, I don't think we have any more questions. So thanks a lot for speaking for us today. It was really cool. And I still enjoy this magic of being able to have a remote speaker. So it's really cool.
Thank you so much for this opportunity. Yeah, it's really nice to meet everyone. I hope it was at least a little helpful.
I don't think you heard our class before because we were muted, so we should clap.
Thank you so much. I really appreciate it.
Okay, thank you, Prarthana. Bye-bye. Enjoy the
Bye-bye.
evening.
Thank you so much.
Thank you.
Just curious how these remote